So hello everyone, welcome to this new session. So in our previous sessions we have discussed DIT-FFT algorithms and two of the very important problems. One is 4-point DFT, one is 8-point DFT, and we have seen its structure also, right? So now in this session we are going to discuss the inverse of that, that is IDIT-FFT, that is inverse decimation in time. Okay. If you know the DIT-FFT concept very well, you can easily write this, because this is just the inverse of that. Okay. So those who have not seen that video, I suggest you all to please see that video, then come and watch this video. Okay, it is available in our channel. And let us start with this concept now. Here in this IDIT-FFT algorithms, inverse decimation in time, that is in the last session we have discussed about an 8-point DFT, right? Okay, considering that in mind, I have drawn one structure for 8-point IDFT here. Okay, in this what are the changes I am going to tell you? Very simple. Okay, I am going to explain you the structure as well as this graph here, which I have already explained in the last session. Again, I am going to tell you all that. So here in IDFT, first consider for DIT what we have considered here. In the input side, the inputs are shuffled, right? In input, and this is output. And here in that in DIT we have discussed that in inputs were shuffled, right, according to the pairs. So now in this case, in IDIT, the outputs are shuffled, inputs are remained as it is, that is capital X of 0, all the DFTs, right? X of 0, 1, 2, 3, 4, 5, 6, 7. The inputs would be remaining in the sequence in case of IDIT. Then here in the output side, the sequence changes, that is, this is X of 0. The bit reversal will be taking place again. After I explained you in the last session what is bit reversal. Okay. According to that, write the outputs here. X of 0, 1, 2, 3, 4, 5, 6, 7. And one simple change here is there, that is, whatever the output side, we should be dividing by n. That is, how much ever the length of the sequence given in the question, that much we should be dividing. For example, if this is an 8-point IDFT, we should be dividing by 8 for all these terms. And that after division of 8, the answers which we get, that would be our final IDFT sequence. Okay. This is one change. One more change is in the structure. Okay, integral structure, where in case of DIT, how we were writing, first we would be writing the pairs of 2, then 4, then 8, right? In case of IDIT, it is ulta, that is, first we would be writing the pair of 8, then pair of 4, then pairs of 2. Okay, this is one change that I am going to explain while solving the problem. One more change is in the inputs here. The downward arrow -1, that is common, I've told you, right? One more change is in DIT, what we would be doing, base 8 to the power 0, we would be writing in the input size, right? So in case of IDIT, where the downward arrow meets, right, that output points should be writing these values, W8 to the power -0, -1, -2, -3. Why this is -0? In case of IDIT, we will represent it as -0, and the values of this in this graph I have told you that we should be checking. How we should be checking? We should be checking anti-clockwise. Okay, that is, if this is W to the power -0, then this is -1, -2, -3, right? Like that. So if this is W power 0 is 1, then W power -1 is this value, then -2, then -3. Okay. Yeah. So these were some of the changes here. Here also in the output side we should be writing, and that's it. So I hope you understood the structure very carefully. So now let's solve two problems that are both are 8-point DFTs only. Okay, 8-point IDFTs. So let's solve those problems. So this is the first question. Calculate the IDFT of the sequence X of k. This is an 8-point sequence. The first value is 0, 2.828 minus j 2.828, followed by 5 zeros. Then last value is 2.828 plus j 2.828. Using Radix-2-DIT-FFT algorithm, we should be calculating the IDFT now. Okay, so here I have drawn the sequence here. I have drawn the lines. Okay, first we should be writing all the inputs and outputs. Okay, so in case of here, the inputs would be in the sequence order I have told you, right? In case of IDFT. Okay, then outputs, bit reversal we would be taking, that is X of 0, 1, 2, 3, 4, 5, 6, 7. Okay, and all we should be dividing by 8, right? So yeah, this much you should be drawing. Then you should be drawing the internal structure. Okay. So here I have drawn the structure here according to the IDFT. First 8, then pair of 4, then pairs of 2. Okay. Hope this is clear. Now we should be writing the values, that is W8 to the power minus 0, minus 1, minus 2, minus 3. And here W4 to the power minus 0, minus 1, W4 to the power minus 0, minus 1, and these and all are 1. Okay. In the output side now. So here the first value is 1, W8 to the power minus 0 is 1. So I write it like this. Then the next value is plus plus, so 0.707 plus j 0.707. Next value is j. Then we have minus plus, so minus 0.707 plus j 0.707. Okay, so here we have 1 j 1 j. Okay, so here in IDFT what we should be doing is whenever we have we get two values, that is when we start from here and here, these two values we should be adding those values first. Okay, which meet at this point. Then after that, after the meeting takes place, whatever the answer we get here, that we should be multiplying with whatever is written in the output side. Okay, after that the final answer which we get, that would be the answer at that point. Okay, then we should be continuing that answer for the next sequence. Okay, like that we should be doing that. I'll explain while doing the problem only. So now this is here, I've written all the inputs and I've written the outputs here. Now we should be solving for 8-point IDFT. Okay. Okay, so let's start now. So first value is 0. From here 0, then from here we have 0. So 0 plus 0 is 0 itself. So here we have first value as 0. Second we have 2.828 minus j 2.828, along with that 0. So this only we would be getting here. Minus j. Highlight it. 0, 0, so 0, then we have 0 and this term, so this term would be getting here 2.828 plus j 2.828. Okay, then we have 0 into minus 1 is 0, then from here 0 into 1. Okay, whatever answer we get, that into 1, so that is again 0. Okay, then 0 into minus 1 is 0 and this term. Okay, 0 into plus this term, so this term into whatever we have here, that is we should multiply, right? So this and this these two terms we should be multiplying now. Okay, take the calci, check that it is in the complex mode. This term 2.828 minus 2.828 I into this term, that is 0.707 plus 0.707 I. You would be getting around 3.998. You can round it off and write it as 4. Okay, I'm highlighting here in box. Okay, that is our answer, 4 at this point. Similarly 0 into minus 1 is 0 and we have 0 here, into j is again 0. So here we have 0, then we have 0 and this term into minus 1, so the signs would be changed now here. So here both would be minus into this term we should be doing, that is this would be minus and plus and plus, right? So if we multiply with minus 1, it should be minus and minus. So here only I am going to change here. So this would be here minus here, so minus, and here minus. Okay, after multiplying again we would be getting the same answer, so again it is 4. Okay, so in the first stage we got these answers. So now continue that 0 and 0, so this is 0 here, 0 plus 0 0, 2.828 minus j 2.828 and 2.828 plus j 2.828. So if we add them, these two terms would be getting cancelled, these two should be adding, that is 2.828 plus 2.828, 5.656. That we would be getting it here, 5.656. Now 0 into minus 1 is 0, plus 0 into 1, it is 0 only. Then we have 2.828 plus j 2.828 into minus 1. Okay, so this would be minus and minus. Okay, and here we have 2.828 minus j 2.828. So one is minus here and one is plus. So these two terms would be getting cancelled and these two would be remaining. Okay, that is 2.828 minus 2.828 is minus 5.656 j, right? J term is also there, into j. Last we should be multiplying it by j. So minus 0.656 I into I, that is plus 5.656 again. Hope you understood this value how we got. Then this part here, 0 and 0, 0 and here we have 0, right? So 0 plus 0 is 0. And here we have 4 plus 4, 8. Then here we have 0 into minus 1, 0, 0, that is again 0. Then we have 4 into minus 1, that is minus 4. Okay, then we have plus 4. So minus 4 plus 4 is 0, into j is again 0. Okay, so these are the values here at the second stage. So now further move to the third stage now. That is, we have 1 0 and 5.656. Okay, it is 5.656 only. Then 5.656 into minus 1 plus 0 is minus 5.656. Then 0 and plus 5.656, so it is 5.656 again. Then we have minus 5.656. Then we have 0 and 8, so 0 plus 8 is 8. So minus 8 and 0, so again it is minus 8. So 0 and 0 is 0, 0. Okay, like this we got the values now. Now these all values we should be dividing by 8, right? First let us divide 5.656 by 8, okay, and we write these four answers here. That is 5.656 divided by 8. 0.707. So our first value here is 0.707. Then we have minus 0.707. Then we have again plus 0.707, minus 0.707. Then we have 8 by 8 is 1. Minus 8 by 8 is minus 1. 0 by 8 is 0, right? So like this we got all these answers. So this is not yet. Now here in the output side the sequence is shuffled, right? So like this only we cannot write our final answer of x of n, because here the outputs are shuffled. So in according to the sequence only we should be writing. So x of 0 is 0.707, comma, x of 1 is here, that is 1. That we should be writing here. Like this only you should not be writing here, because this is for IDFT where outputs would be shuffled, right? So you should be keeping that in mind. Then x of 2 is again 0.707. X of 3 is 0. X of 4 is minus 0.707. X of 5 is minus 1. X of 6 is again minus 0.707. X of 7 is 0. Okay, so this is our final answer for IDFT. So hope you understood this problem. Okay, so please go through this problem again. Okay, so now let's solve one more problem related to IDFT. So this is the next question. Calculate the IDFT of the sequence 0, 2 plus 2j, minus 4j, 2 minus 2j, 0, 2 plus 2j, plus 4j, 2 minus 2j. So this is again an 8-point IDFT. Using DIT-FFT algorithm we should be solving this. Okay, so now let's solve it quickly. So here I have written the structure now for IDIT. So hope this is clear. The values I have written it for output side here, 1 plus plus and j minus plus, the values 1j and 842 sequence. So inputs I have written it in order, outputs are shuffled. That divided by 8 symbol I have not written, but when I reach here, automatically I will divide the answers by 8. Okay, so like this I have written. So now let's solve this problem. So these are our inputs. Start from here. This 0 would be coming here, then this 0. So 0 plus 0 is 0 only. First answer is 0. Okay. Next is 2 plus 2j and 2 plus 2j. That is 2 plus 2 is 4. 2j plus 2j is 4j. So 4 plus 4j. Then minus 4j plus 4j, that is 0. 2 minus 2j and 2 minus 2j, that is 4 minus 4j. Okay. So then we have 0 into minus 1 is 0, and here we have 0 into 1 is again 0. Then we have 2 plus 2j into minus 1. So that is minus 2 minus 2j, and we have 2 plus 2j, right? So here minus 2j plus 2j would be getting cancelled, and plus 2 minus 2 would be getting cancelled. We would be left with 0. Okay. So then we have 4j into minus 1, that is minus 4j, and here we have minus 4j, so that is minus 8j into j. Okay, that is minus 8i into I, that is equal to plus 8. Okay, so again we got here the answer as 8. And similarly 2 minus 2j into minus 1, that is minus 2 plus 2j, and here we have 2 minus 2j, that is here minus 2 plus 2 would be getting cancelled, plus 2j minus 2j would be getting cancelled. Again we would be left with 0. Okay, hope you understood this first step. So now let's get to the second step now. 0 plus 0 is 0. 4 plus 4j, 4 minus 4j, that is plus 4j minus 4j would be getting cancelled, and 4 plus 4 is 8. Okay, then we have 0 into minus 1, 0 and 0, so that is again 0. 4 minus 4j into minus 1, that is minus 4 plus 4j, and here we have 4 plus 4j, that is minus 4 plus 4 would be getting cancelled. 4j plus 4j is 8j. 8j into j, that is 8i into I, that is minus 8. Okay, so here we got minus 8, and here we should be having 0 and plus 8. So 8, 0 plus 0 is 0. 8 into minus 1 is minus 8. Okay, minus 8 plus 0 is minus 8 into 1, that is again minus 8. Then here we have 0 into 1, 0, and 0 into j is again 0. Okay, so these are the terms we got here. So now let's get to the next part. 0 plus 8 is 8. Then we have minus 8 into minus 1, minus 8 plus 0 into 1, that is again minus 8. 0 minus 8 is minus 8. Okay, here we have minus 8 into minus 1 plus 8, and 0 into 1 is again plus 8. 8 plus 0 is 8. 0 into 1, 0 and 8. So here we have 8 again. So here minus 8 plus 0 is minus 8, and 0 into 1, 0, and here we have minus 8 into 1. So again minus 8. So these are the terms we got. Now nothing much to do. All these terms we should be dividing by 8. So 8 by 8 is 1. So this is 1, minus 1, minus 1, 1, 1, 1, minus 1, minus 1. So these are the answers which we got here after dividing by 8. So now this, like this only, we should not be writing in sequence. We should be writing in terms of x of n, because the outputs are shuffled, right? First value x of 0 is 1. X of 1 is 1. X of 2 is minus 1. X of 3 is minus 1. X of 4 is minus 1. X of 5 is 1. X of 6 is 1. And x of 7 is minus 1. So this is our final x of n sequence of this DIT-FFT problem. So hope you understood this problem, guys. In this session we have discussed the problems related to IDFT using the butterfly structure. Okay, Radix-2-FFT algorithm. This is also called as butterfly structure. Okay, we can call it as butterfly structure in short. But in the question they won't be asking, like, they won't be specifying any word called as butterfly. They would be mentioning either Radix-2-FFT algorithm or DIT-FFT algorithm. So hope you understood these kind of problems very well. So in the next session we are going to solve problems related to circular convolution using DIT-FFT algorithm. So already we have discussed what is circular convolution. Nothing much to do. We are going to solve the problems only in the next session, but the method would be different. That's it. So hope you understood these concepts. Like the video if you understood. Your like matters a lot for us. So please like the video, guys. Support our channel. Share this to a huge number and stay updated to this digital signal processing sessions. Okay. That's all, guys. Thank you.